Hey, what's up? Welcome back to another episode of Hacking Smart Contracts for Fun and Profit. Today we're looking at challenge number 10, Freerider from Damn Vulnerable Defi. So, a new marketplace of damn valuable NFTs has been released. There's been an initial mint of 6 NFTs, which are available for sale in the marketplace, each one at 15 ETH. A buyer has shared with you a secret alpha. The marketplace is vulnerable and all tokens can be taken. Yet, the buyer doesn't know how to do it. So it's offering a payout of 45 ETH for whoever is willing to take the NFTs out and send them their way. You want to build some rep with this buyer, so you've agreed with the plan. Sadly, you only have 0.5 ETH in balance. If only there was a place you could get free ETH at least for an instance. Well, maybe there is. Okay, let's check out the contract. Okay, so we got two contracts here. The first one is called Freerider Buyer. We're importing a couple Open Zeppelins here at the Open Zeppelin things at the top here. Address, reentrancy guard, the IERC 721, and the 721 receiver. Okay, so we get into the contract. We see it's inheriting the reentrancy guard and also the 721 receiver contract. So I'll check out these variables. We have one called partner, NFT. We have a job payout here that's hard coded to 45 Ether. And we have a variable called received. This is going to be keeping track of how many NFTs we receive, or this contract receives, I should say. In our constructor here, we're taking a couple arguments, partner, and then an address for the NFT. So we require the message value to be equal to the job payout. So when they launch this contract, it's going to be looking for 45 ETH to be associated with this deployment. And then the partner, it's going to be us. And then the NFT, we're just initializing here as an IERC 721. And then also we're just approving the NFT here for the message sender. Okay, so next we just have this function. We just have one function here. It's called on ERC 721 received. And we can see up here, there is a link to check out more information about this function. So let's just do that. I have it pulled up conveniently. So this is it, EIP 721 non-fungible token standard. Basically, all you have to know, the gist of this, you can kind of read through it on your own if you want to kind of get a more in-depth understanding of it. But we can see here, this standard provides basic functionality to track and transfer NFTs. So if you want your contract to track and transfer NFTs, you need to embed this function, and it's going to make things a lot easier. So we can also, this is just a basic like boilerplate code, but we can also include some of our own logic here. In this logic, if we read through it, it's going to check if the contract has received the NFTs, and if it receives all 6 NFTs, it's going to send the job payout. So that is the gist of that. Okay, next let's check out the Freerider marketplace. So we have a couple Open Zeppelin things up here, and also we are importing the damn valuable NFT. We look down here. We're creating an instance of this damn valuable NFT, and we're calling it token. And then we also have a variable here called amount of offers. Then we have a mapping called offers that maps a uint to a uint. And then we have a couple events here, NFT offered and NFT bought. So if we look down into the constructor next, it's going to take an argument of amount to mint. That's going to be how many you want to initially mint. And it requires the amount to be less than 256, So 256 is going to be the maximum amount of NFTs mintable. And then it initializes the token right here. And then finally, it loops through the amount you want to mint, and then it will do a safe mint to the message sender. And we know it told us initially the initial mint was 6, so it's gonna, loop through this 6 times and then send it to the message sender. Okay, next we have the function here called offer many. We take in 2 arguments here. It takes in 2 uint arrays. The first one is token IDs and the second one is prices. So basically, yeah, it's going to take in token IDs and prices. So if you want to offer many up for sale, you're going to select which token IDs you want to offer, and then you need to attach an associated price with that token ID. So right here, it just checks the length of the token IDs is greater than 0, and the token ID's length is equal to the prices. So it's just here, this check is just making sure there is a price associated with each token ID. And then once we pass that check, it will loop through the token IDs and call this helper function right here with the associated token ID and price, and it's called offer1, which is right below here. We can check it out. So we go through this loop and then we trigger this and we go in here. We pass in a token ID and the associated price. We do a check. The price is greater than 0. We require the message sender to be the owner of the token. So you can't make a token up for offer that you're not the owner of. And then we just do a check here that we're approved for that token. The person the owner is also approved to sell the token. Okay, and then finally we get the price here. We have the mapping here. This is the offers, and then we put in the token ID, and then that's going to give us, it's going to spit out a price here for us. And then we just increment the amount of offers. And finally, we put out an event here called NFT offered. So it's just letting you know there is a new token up for offer. So next we have a function here, by many. It's taking in just 1 argument, and it's taking in it's looking for a uint array and called token IDs. So you just basically, you call this function and then you place in which tokens you want to purchase. Then it will loop through your token IDs you want to purchase, and then it will call this helper function called buy1 with the associated token ID, which is right below here. So we loop into here. We get the price to pay it's going to reference this mapping here, and we require the price to pay is greater than 0, and we also require the message.value is greater than or equal to the price to pay. So when you call this function, you're going to also have to attach a value to this token, which we know is 15 ETH, which is, it told us in the beginning, each token is going to be 15 ETH initially. So we'll have to call for, it's expecting us to attach, if you want multiple tokens, you're going to have to attach 15 ETH per token, is the intended logic. So once we check, make sure the message value is correct, we decrement the amount of offers, we transfer from the seller to the buyer, then we pay the seller, and then finally we emit that the NFT is bought. Okay, cool. So what is the vulnerability here? I'm going to tell you. There's actually two vulnerabilities here that are working, that will be working in our favor and working against the marketplace in a very bad way. So basically, I'll just walk you through. It's contained in this function right here. So basically, what we're gonna do, we're gonna trigger this function buy many. And we'll pass the token IDs what we want to purchase, and then we'll loop down into this buy one function, right? So this buy one function, if we just kind of step through it, we get the price to pay, which is going to be 15 ETH. So then next we'll pass this function, it's greater than 0, and then if we will attach 15 ETH to this transaction. So then we will pass this next function called required message value greater than price to pay. Okay, cool, we'll pass that because we'll have that 15 ETH. We'll decrement one of the offers. And then here is the first problem we encounter here. So when we get to here, it's going to transfer from the seller to the buyer, right? It says here. And then at this point, we will be the new owner, right? So maybe you see where I'm going with this. The problem is when we get to this next function to pay the seller, the token.owner of, when you pass this, when you plug the token ID in here, the owner of is going to be us. It's not actually going to be the seller, right? So the marketplace, this is a bad gotcha here, because the marketplace is not going to pay the seller. It's actually going to pay us. So that's bad. I think we could mitigate this just by switching these two functions around. That should, if we pay the seller first and then transfer, I think that should probably mitigate that problem. And then when we come back up to the top, we'll go and loop through this one more time. We'll pass in to this function, the buy one. We get the price again, which is 15 ETH. It's greater than 0. We'll pass this check. And then here's the next issue. When we get down here, it's going to require the message.value is greater than price to pay, which it's going to reference the initial 15 ETH, right? So basically, it's going to think we have enough money because we haven't done proper accounting here to say, hey man, this guy, we spent the ETH, it's gone. But there's no check here to make sure the ETH was spent after we purchased the token. So when we go back up to the top here, it's just going to go, yeah, cool. He attached 15 ETH here, which is greater than the price to pay. So give him the token. So that's the second kind of bad logic here, or bad accounting, bad situation here we're going to run into. So we should have some sort of check to make sure the ETH was spent, but because we don't, we can just keep spending the initial 15 ETH every time we get every time we loop around here. It's gonna give us just the same 15 ETH. So yeah, every time we loop back around into the buy one, it's gonna say, hey, cool, yeah, he has 15 ETH, boom. And then every time, boom, yeah, cool, he has 15 ETH. You get the point. So that's the attack vector. And we don't have 15 ETH. I should mention that. So how we are going to how we're going to get that 15 ETH is we're going to use a flash swap from Uniswap, which is cool because we haven't done that yet. So we're going to learn something new today. All right, let's just get into the code. So I copied a couple things here just to get us going. The Uniswap v2 factory, the v2 pair, and the IERC 721 receiver contract. and also the Damn Valuable NFT. Okay, and also we'll need a couple interfaces. The first one we're gonna need is WETH. We're gonna need, because that's what we'll be taking a flash swap in WETH. Now some people call it WETH. I'm just not down with that. I'm gonna call it WETH. Okay, so the first thing we'll need here is the deposit. Make it external. The next thing we'll need is the withdrawal function. Make this one external. And finally, we will need the transfer function. Oops. Okay, that's good for that interface. Next, we will need an interface for the marketplace. And the only function we need here to interface with is the buy many. Okay, and that's that. So that's our interface set up. Next, we will just start setting up our contract. We call this rider, oops, if I can spell, rider attack. And we need to make this inherit from the ERC 721 receiver, because we want to be receiving NFTs into this contract. Okay, so next we'll set up some variables and some references to this stuff above. Factory, the unipair, let's call it unipair. The Damn Vulnerable NFT, the WETH, the marketplace, and finally we need a reference to the buyer contract. Okay, so we'll just set up our constructor. Factory called factory. Oops. Pair. Pair. The damn valuable NFT. The WETH. And the buyer. Okay. Next, oops. Okay, next we will initialize the above arguments. All right. So we say factory. Pair. Oops. WETH, marketplace, and the buyer. Okay, now that we've initialized our inputs, we can set up our attack. Func. We'll just call this attack. We need an input. We'll name it amount. Make it external. Okay, so in our flash swap, in our attack, what we want to do is trigger a flash swap from Uniswap. And then we will walk through a bunch of logic, and then, yeah, that's going to be... you know what? Let me just go to the Uniswap docs page, and maybe I'll step through it from there, and that's going to make some more sense. Okay, so I have the Uniswap docs page pulled up here. This is the V2 docs, and just search flash swap, and you're going to get this page, and it's going to walk you through exactly how to do it. Very good documentation. Good job, Uniswap. So I'm going to just give you a high level overview of this stuff, so we don't have to, read all of this. Basically, what you want to do, you're going to want to call this swap function on the V2 pair contract. And basically, if we just kind of, leave this, if we just call this and we leave this last, so there's this last argument here, it's just called data, whatever you want to say. And it's called, it's a bytes call data, right? So the idea here is if you just leave this last input field blank, it's going to just call a normal swap. But if you put anything into this last field here, it's going to trigger a flash swap. That's how it knows it's a flash swap and not just a normal swap. You can kind of read through this logic and it maybe make a little bit more sense to you, but if you see it, like if you see right here, if data.length, which is the last field here, is greater than 0, the contract transfers the tokens and then calls the following function on the to address. So it calls this function the Uniswap v2 call function, which is basically it's the flash swap function. And then you can put a bunch of your own logic in, repay the swap, and plus, actually another thing to note here is there's a 0.3 LP fee here. So whatever you do, you need to repay, you'll do whatever transaction or logic you want to do, and then you need to repay the initial amount plus a 0.3% LP fee, which we'll just calculate and repay it together with the initial amount. So that is basically the flash swap. I highly recommend on your own time you just kind of check this page out and kind of walk through it, and it's pretty clear. I'm going to just copy this code here. Actually, this is some boilerplate stuff that will just get us going. And let's just get back to the coding. So that's what we'll do here. We'll call this swap function on the Uniswap pair, and we'll pass in this initial amount for the amount 1. So we just want to borrow WETH, so we just need to pass in an amount to the first argument here. This can be 0. Address will be us, and then data, so this is the field. If it's just blank, normal swap, right? If we put anything in here, this is going to be, say, give me some money, whatever. You just put something in there and it's going to know, cool, this is a flash swap, trigger into this next function here. That's all we need for that though. So once once Uniswap knows it's a flash swap, it's going to be looking to call this function right here, this v2 call, which I copied from from that docs page you saw. So here it is. This is just some boilerplate stuff to get us going. We have to make this external. And so this right here, it's just grabbing the address of token 0 and then the address of token 1. And then we are just asserting that the message sender is a v2 pair. Also here, we need to pass in the factory, right? Because that's what our factory interface. This is what we called it above and how we initialized it. So, like it says, the rest of the function goes here. Okay, so let's just put the rest of the function. So at this point, we're going to pass in the amount into here, which is going to pass down into here. And then that is going to be, because we're referencing the WETH contract, this is going to give us some WETH. At this point, we will have our WETH and we can run our own logic here. So whatever we want to do, we just put it in here, and then we just got to make sure we repay the flash loan with the fees, and then we're good. So let's just step through the logic of what we want to do here. What are the steps we have to pass through? So the first thing we want to do is we want to unwrap our WETH into ETH. Because this marketplace contract, it's going to want ETH and not WETH. So that's cool. We just unwrap it, and then we need to create an array for the NFTs, because if we look at this marketplace function right here, this buy many function, it's looking for a uint array of token data, right? So we can't just pass it in normal token IDs. We need to just create an array, and then we can pass it into that function. So we'll unwrap it, create an array for the NFTs, I guess maybe we should say the token IDs. For the token IDs. And after we do that, we can, buy many NFTs. Buy many NFTs. At that point, we're going to have the NFTs in our possession plus profit, because every time we go through that loop, it's going to do that bad logic, and actually the marketplace will pay us because it believes we are the initial seller, but it's just confused and it's just bad logic. So we will have the NFTs plus a good profit. At this point, we'll calculate the fees to repay. Okay, we will calculate the fees. We will need to, after that, before we can repay, we will need to rewrap the ETH into WETH. Then we can repay the flash swap plus fees, and then transfer tokens to buyer. Okay, yeah, that seems like the right sequence. One thing that I will just do here before I forget this. So like we were reading earlier here, we'll need this function in order to receive NFTs. So I'm just going to copy this in and just paste it. We don't need this extra logic. And we don't need this modifier here. So this will allow us to receive NFTs, and also we will need this contract to be able to receive Ether. So we need to use this helper function. This is the built-in Solidity function that allows us to receive Ether. Make it external and payable. Okay, so now we should be able to receive NFTs with this function, and we will be able to receive Ether, no problem. Okay, let's just get into the coding. So we need to unwrap the WETH. So we'll just withdraw. We'll pass in the amount 0. Okay. Next, we will create an array. Hold it in memory. And call it NFTs. And then this is how we initialize the array. New. And then we will make it length 6. Okay, next we need to populate this array. So we want to populate it with 0 to 6 token IDs, right? The first 6 token IDs. So we'll just use a loop to do this. Less than 6, I plus. Okay, and the way we do this, we'll just say NFTs, I equal to I. Okay, so now we've created an array and populated with token IDs. Next thing we want to do is just trigger the by many with the array. It's just called NFTs, and we will also need to attach a value on here. And the value we know is 15 Ether. Okay, so next we should have the NFTs in our possession plus a healthy profit. So we will need to calculate the fees on this, right? We'll just call this fees. And the way we do this it's a little bit weird, but I'll just type it out first and then explain it. Amount times so I think if you've worked with Solidity before, Solidity doesn't work with floating point numbers. So the way the way we'd want to do this normally, we would say like amount times, so the fee it's 0.3%. So we'd want to go like 1.003, right? And then this would give us the amount plus 0.3% added onto the amount. But because we don't have access to the floating point numbers, we have to do the calculations like this, and we're going to get basically the exact same thing. So next we're going to rewrap the WETH. We'll call it deposit, and then we need to attach a value on here. We will attach the fees. Oh, I spelled it wrong. Fees. Okay, so now we've rewrapped our ETH into WETH. We can repay our flash loan. We transfer to the message.sender. So the message.sender in this case is going to be the V2 pair contract. And the amount, we'll just say fees. Okay. So now we've repaid our flash loan. The last thing to do is transfer tokens to the buyer. So we need to transfer 6 tokens. So we'll use a loop for that, because we need to call this function 6 times. That's less than 6. I plus plus. Okay, so okay. So we will call the DVNFT, and we'll call safe transfer from. We would transfer from us to the buyer, and It's NFTs. Okay, that should be it for the. Let me see. Yeah, that should be good for the attack contract. Let's check over it. Yeah, looks good. Okay, let's code up our test. Okay, here we can say this.hack equal to await. We called it rider attack. Oh, sorry. Ethers dot get contract factory. We need to make it deployed from the attacker. We will chain a deploy function on here, and then we need to deploy it with the same sequence as we have here in our constructor here. So factory pair NFT WEF marketplace buyer. Okay. This dot factory dot address. Oops. NFT dot WEF dot and this dot okay, let me just double check that. Factory pair NFT WEF. Okay, looks good. Next, we will just call hack.attack. And we will pass it the NFT price. Oops. NFT price. Okay, so that looks good. Let's try it out. Save it. Okay, here we go. Freerider, I believe this is called. Okay, moment of truth. Okay, compiling, some warnings, not a big deal. Oh, and we passed. Okay, so that is it for the Freerider challenge. I hope you learned something about flash swaps and NFTs, and we will check you on the next one.